Hi, this is the day 7 video, and we are going to work with functions and the function questions that go along with the graphs. On the first two slides here, I have some vocabulary words that you will need to write down and their definitions. First of all, you're going to need to write down function. And a function, let me get my pen. Okay. Function is a relationship that assigns exactly one output value for each input value. How can you tell if a graph is a function or not? Is you got to ask, does it pass the vertical line test? That's what I mean by VLT, is vertical line test. The domain is the set of all input x values, and you identify those from looking left to the right. The range is the set of all y values, and those you look up and down, like where the y-axis would be. Okay, the other definitions that you need would be maximum, the highest point of the curve, and the maximum only refers to the y value. It's the highest y value. A minimum would be the lowest point of a curve, and again, you look at the y value. X-intercept is the ordered pair where the curve crosses the x-axis, and y-intercept is where the ordered pair, it's the ordered pair where the curve crosses the y-axis. Okay, the other words that we have, we're going to be talking about something, the interval positive, and we're going to be talking about interval negative. The interval positive is the section of the curve that's above the x-axis. So you name it from left to right. And then interval negative is a section of a curve that's below the x-axis. And then we have end behavior. If you put your finger on the curve in the middle of the graph as you trace to the right, what happens to the y value? As x goes to infinity, y goes somewhere. And usually the y goes to is either going to be infinity or negative infinity that you'll fill in these blanks right here. So the end behavior is what's happening at the graph to the right, to the left. It's going up, down, decreasing. Okay, let's take a look at a graph and answer some function questions in relation to this graph. Here we have a graphed line. First of all, I want to know, is it a function? Well, does it pass the vertical line test? Yes, it is a function because it passes the vertical line test. Then I want to know the domain, the set of all x's. Well, we've got points that are all over this line. Those points use up all of the x values. As the graph continues in both directions, you will be hitting all the y values. So I'm going to put a double bar R there, and that means all real numbers. That's an abbreviation for all real numbers. Now the range, what can the y coordinates be of all these points? Well, the range is like the x coordinates. It can be any number it wants. So for a line, a straight line, your domain and range will always be all real numbers. And the function, it's always a function. Maximum or minimum, do we have a highest point on this graph? We do not, because the graph continues to go off in both directions, so we're not going to have a highest point, and we're not going to have a lowest point. The x-intercept, where it crosses the x-axis, so we take a look at that point right there. Notice how the grid is being marked. We have 1, 2, 3, 4, 5. So we're counting off in ones. So my x-intercept is I name this point right here. So I do 1, 0. The y-intercept, where does the graph cross the y-axis? So I'm looking at it right here. So my y-intercept, I name that ordered pair, and I'm looking at 0, 1. Okay, now to answer the question about the interval positive and interval negative, the interval positive you have to ask, where is the graph positive? Where is it above the x-axis? So if we look at it above the x-axis, this region right here is where it's above the x-axis. So what we say to write that out we use the x's out here. We're coming from negative infinity, and then it hits this point right here, and when it hits that point on the x-axis, that was 1. So the interval positive, where it's above the x-axis, is from negative infinity, because we read it left to right, to 1. And at 1 on the x-axis, that's when it dips below the x-axis. Interval negative is where it is below the x-axis. It's below the x-axis in this region right in here. So we start and we read it left to right. We start with the x-coordinate of that x-intercept, and it was 1. And then how far? Well, let's see, it keeps going. It has an arrow down here. It keeps going, and so I'm going to infinity. Not because of the arrow, but because of my x-coordinates here, will continue to go to infinity as that line progresses downward. End behavior, you need to take a look at the ends of the lines, where the arrows are. And as x goes to infinity, that means you're looking at the positive part of the x-axis right here. As the x-axis continues to move towards the right, where does this graph go? Well, it's moving downward. It's moving down, and if it's down, we're going to say to negative infinity. As x goes to negative infinity, that's over here on this x-axis, as it progresses to the left, this graph right here is going up, up, and away, and it's going towards positive infinity on the y's. Let's take a look at this graph, this curve. Well, first of all, is it a function? Does it pass the vertical line test? And to that, I'm going to answer yes. It passes the vertical line test. My domain on here, what can all my x's be? Well, as I look at this graph and I look at the x-axis right here, look at all the points that are on the graph. And then how the graph is going to slowly go up and it goes down over here. Well, it's eventually going to open up and use up all of those x's. So as it does that, if it's using all the x's, we're going to say that our domain is the all real numbers. My range, well, what are the y values? Well, it's going to continue to go up here and keep continuing to go down there and progressively just kind of open up. So eventually it's going to hit all the y values, so we say all real numbers. Now, not all graphs are all real numbers. Just this example and the previous example happen to be that way. Okay, a maximum, highest point on the graph. When I look, I'm going to change something here. Whoopsie. Put my all real numbers back. The maximum, highest point on the graph. There's a maximum because it is one of the high points on the graph. So when I name that maximum, I just use the y coordinate of that point. And it looks like it's about 8, so I'm going to say 8. My minimum is the lowest point on the graph. Let's see, 1, 2, 3, and then over to negative 4. So my minimum, I read in relation to the y-axis, so I want to say that that is going to be my negative 4. That's the lowest y value on the graph. X-intercept, well, it looks like we've got quite a few of them. We've got it here, here, and here. So I have 3 x-intercepts. Those x-intercepts appear to be at negative 1, 0, and at 2, 0, and at 4, 0. My y-intercept only crosses once, and that was up here where that maximum was. So my y-intercept, I say, is 0, 8. The interval positive, well, we have several regions where it is above the x-axis. Interval positive is you name it where it's above the x-axis. So I'm highlighting where it's above the x-axis. And I name the intervals. So I name the intervals according to the x-intercepts. So from left to right, this was 1, and this was 2. So my interval positive, I can say it's from 1 to 2, and it is from here, and it keeps going up, so it's going to infinity, so I'm looking at 4, infinity. My interval negative is where it would be below the x-axis. So here it is below the x-axis. So to name the interval negative, I'm coming from negative infinity, and then I hit right here. So I say negative infinity, comma, and then that, whoopsie, that should have been a negative 1, negative 1. And negative infinity, negative 1. And then this region, where it is negative on this U shape right here, I go from 2 to 4 is another interval where it's negative. My end behavior, well, as x goes to infinity, that is, as x continues to go down here to the right, where's this graph up here going? Well, it's going to positive infinity. Notice how the arrow's pointing up? So the arrow's going up, positive infinity. As x goes to negative infinity, that would be the graph as the graph continues over on this side, the left side of it. Where's the graph going? It's going down. So we say negative infinity.